Geometric sequences. Example 1. Find Tn and T10 of the geometric sequence 1, a quarter, 1 over 16, 1 over 64, ... So this little yellow box here in the top right hand corner just gives us some statements about geometric sequences. The third one is the little formula that we use. It's in the formula book. You do not need to learn it off. So Tn is equal to a or to the power of n minus 1. T1 stands for term 1. That's equal to a. Or the common ratio can be found by dividing term 2 by term 1, or by dividing any term, like let's say term 6 by the previous term. So that would be term 6 by term 5, and so on. And this little formula at the bottom here represents that. So Tn plus 1 would represent the next sequence, and Tn would represent the previous sequence. So that's just like saying term 2 divided by term 1, or term 4 divided by term 3, or term 10 divided by term 9, and so on. So that will give you the common ratio. So the third statement here, the formula for Tn that's given in the formula book, no need to learn it off. So I'm going to start by writing out my sequence. I'm going to label the 1 as A. That's the first term. I'm going to label the 1 also as T1, term 1. I'm going to label a quarter as term 2. And to get the common ratio, I'm going to divide term 2 by term 1, which is going to be a quarter divided by 1, which is a quarter. So the common ratio is a quarter, so we're multiplying by a quarter each time to get to the next term. Now it's important to note that it was told in the question that it's a geometric sequence. So that's how we know that there is a common ratio. So that's why we can use this statement here, or is equal to T2 over T1. So then we're going to use our formula. Again, this is given in the formula book. No need to learn it off. Tn equals A times or to the power of n minus 1. So A, we swap for 1 with a set of brackets, or we swap for a quarter with a set of brackets, and that's to the power of n minus 1. So 1 times a quarter is just a quarter, and a quarter to the power of n minus 1. This is fine to use, but the book actually rewrites it. So this would be one way of working out the question. So the book rewrites it as 1 to the power of n minus 1 over 4 to the power of n minus 1. And the reason that 1 to the power of n minus 1 becomes 1 is because 1 to the power of anything is still just 1. So 1 to the power of anything gives us 1. So we can rewrite 1 to the power of n minus 1 as 1. So it's okay to just use this and continue on the question. But this is just another way of writing it out. So it's just applying the power to the numerator and the denominator instead of using brackets and applying the power just to the outside of the brackets. So here we're applying it to the numerator and to the denominator. This is one of the little rules, formulas from our indices page in the formula book. And it states that a to the power of minus p is equal to 1 over a to the power of positive p. So using that rule in reverse, 1 over 4 to the power of positive n minus 1 becomes 4 to the power of minus n plus 1. So it's using this rule in reverse. So the 1 over 4, the quarter, becomes 4, or 4 over 1 becomes 4, and then the powers change sign. So the n becomes minus n, and the minus 1 becomes positive 1. So I've just highlighted to show where all the different bits come from. So the yellow part is the 1 over, and we can see that in the formula. The blue part is the 4, so that would be the a in our formula. And the n minus 1 would be the p in our formula. So again, it's the rule in reverse. So we're getting rid of the 1 over. So we still have the a, which is 4. And we now have to the power of minus p. And the original p was n minus 1. So it's going to be minus times n minus 1. And minus times n is minus n. And minus times minus 1 is positive 1. So that's how we get from here to here. And then we can just rearrange it to have 1 in front of the minus n. So it doesn't matter which way you write it, but just to show this is the way that the book presents it. So as I said, you can actually just stick with this. This is probably a little bit easier and there's less work involved, but they mean the exact same thing. So as I said, these two mean the exact same thing. So a quarter to the power of n minus 1 is the same thing as 4 to the power of 1 minus n. So we then have to find term 10. So we found Tn, so either of these will work for Tn. They both mean the same thing. To find T10, it's going to be a quarter to the power of 10 minus 1. 10 minus 1 is 9, and a quarter to the power of 9 is 1 over 262,144. So 262,144 on the base, on the bottom, so that's our denominator. Or using the nth term from the book, which is 4 to the power of 1 minus 10, replacing the n for 10, we get 1 minus 10 gives us minus 9. So 4 to the power of minus 9 again gives us the same answer, 1 over 262,144. So it's up to you which nth term you use. The top one is less work, but both give you the exact same answer.